Hello, my name is Kayla Dawson, and this is part 2 of hacking the Keyoptrix One virtual machine. Okay, starting here on this far left side, I'm logged in as root in my Kali machine, and I run MSF console to start up Metasploit. Once that's finished loading, I run use auxiliary /scanner /SMB /SMB _version. What I'm going to do is use this scanner to identify what version of Samba is running on the Keyoptrix One virtual machine. Then I set the rhost to 192.168.33.10. Rhost refers to the IP address of the target host, which in this case is the Keyoptrix One virtual machine. Next, I ran the script. What we see here is the version of Samba running is 2.21a. On my host machine, I ran a Google search on Samba 2.21a. At the top of the search results is Samba version 2.28, remote code execution on the exploit database website. I click the link and see the code to run remote code execution against the machine. And next, I gathered the raw code of the exploit and copied all the raw code in what you see right here in the middle. I saved it in the Kali B editor. And once I finished copying it, making sure everything was good to go, I saved it. Then ran the command gcc 10.c switch O 10 to output the file. Next, to run the executable, I ran command /10. The output showed a list of menu options to select from to execute the exploit, and that's what we see here on this far right side. Alright, and right here I run command /10 switch B for brute force, 0 for Linux, and our IP address right here for the Keyoptrix One virtual machine. So we go ahead and run that, and we see here Samba 2.2.8 remote root exploit, brute force mode Linux, host running Samba, and our message that we want to see is that it worked. And we see now that we're logged into the Keyoptrix One virtual machine. So what I did next is ran command pwd, which will print the current working directory, and we see here that I'm in the temporary folder. Next, I ran command change directory to take myself back a directory, pwd again, and I see here that I'm now in the / directory. Alright, so the next step is to add a user to the Keyoptrix One virtual machine, and first, just to make sure that I am root, I do cd / just to take myself back from the temporary file, and I run command ls, and what I see here are the other directories. From there, I ran command whoami, and I see that I'm root, so that's good. Next, just out of curiosity, I want to see what other users are on the machine, so I run cat /etc /password, and I see here all the list of registered users on the Keyoptrix One virtual machine. So next, what I did was run command user add Dawson, and we see here command not found, so that command doesn't work. So to locate where I can run user add and to locate that program within the binary, I run locate user add, and we see here 3 results: /user /sbin /user add /user /share /man /man8 user add 0.8.gz, and then we see etc default user add. So from there, what I do is I see that user add, just doing user add doesn't work. I run command /user /sbin /user add switch OU 0 Dawson, and not only am I adding myself as a user onto the machine, I wanted to give myself elevated privileges, so I have admin access. I run that, nothing comes back at me saying that it didn't work. Next, I ran password Dawson to set the password for the Dawson login, and I see here a prompt for a new password. I type my password here, root is the best, typed it again, and we see here that the password for user Dawson was changed, and all authentication tokens updated successfully. So we added Dawson, we added my last name to the Keyoptrix One virtual machine. Let's see if everything works. And right here on this left-hand side, I go ahead and I type in Dawson. My password root is the best, and I see here that I am logged in and root at Keyoptrix Dawson. So I'm logged into the system and I have root access. To prevent privilege escalation, the following mitigation techniques need to be implemented. First, enforce the principle of least privilege. Users should only access resources that are necessary for performing their job functions. 2. Patch and update software. Apply patches to existing vulnerabilities in software and systems. Update software and operating systems to the newest version available to minimize the risk of a threat actor executing a cyber attack by exploiting unpatched vulnerabilities. 3. Conduct routine vulnerability scans. Continuous scanning of all components in IT infrastructure makes it difficult for an attacker to gain access to a network. 4. Monitor network traffic and behavior. Use user and entity behavior analytics tools to monitor network traffic and behavior. This can help identify suspicious or abnormal activity that could indicate a threat. 5. Implement a strong password policy. When users create work accounts, the password should have a length of, at minimum, 8 characters, 1 capital letter, 1 lowercase letter, and 1 special character. Include multi-factor authentication, such as push notifications or SMS PIN numbers as an additional layer of security. And lastly, implement routine security awareness training. Provide security awareness training throughout the year to ensure that all members of an organization are educated on social engineering attacks, cyber threats, and security policies. Explain how weak passwords, clicking seemingly normal links or attachments in emails, and ignoring warning message prompts can lead to a threat actor executing a cyber attack against them or the entire organization. Buffer overflow is when a program or process attempts to write more data to a fixed length block of memory or buffer than the buffer is allocated to hold. It's a type of denial of service attack used by threat actors to overwhelm a system to the point where it crashes. This attack involves the threat actor sending code to a program located in the target machine that exceeds the amount of data held in a buffer. This attack would fall under the category of an active attack on the basis of modification and impact. In a buffer overflow attack, an attacker modifies data held in a buffer, and the impact of that input results in denial of services. Privilege escalation is when a threat actor gains access to an existing user account or system due to broken access control, weak passwords, or system misconfigurations. There are 2 types of privilege escalation attacks, horizontal and vertical. Horizontal privilege escalation is when a threat actor gains access to an existing user or device account and uses it to gain access to another account. For example, an Amazon area manager being able to access another manager's Amazon A to Z account and uses the access gained to modify pay information in their ADP account. For this attack to be successful, the area manager has to bypass the multi-factor authentication in place to gain access into the other area manager's ADP account. They could do this by conducting privilege escalation while the other area manager is already logged into their ADP account. Since the session is already authenticated, there's no multi-factor authentication prompt to interact with. Vertical privilege escalation occurs when a threat actor exploits system misconfigurations, vulnerabilities, or inadequate access controls to gain admin permissions so they can access other resources that are only allowed to users with elevated privileges. For example, if an employee that has been working at a company for 10 years, let's say a security analyst, has been promoted to the senior position they believe they deserve, decides to attack the company from within, they could exploit existing vulnerabilities that have been identified within the network and haven't been patched yet to execute their attack. Privilege escalation would fall under the category of an active attack because a threat actor is modifying resources or disrupting device and network services. A rootkit is a program or a collection of malicious software tools that give a threat actor remote access to and control over a computer or other system. Rootkits are installed in a social engineering attack such as phishing, where the user is tricked into clicking a link or attachment that consists of malicious software. This results in a backdoor for the attacker to use in controlling the target machine remotely. Rootkits often attempt to avoid detection of its presence by disabling endpoint malware and antivirus software. Rootkits would fall under the category of an active attack because a threat actor is able to make modifications to system configurations, such as disabling antivirus security, removing files, or installing malware. A Trojan is a form of malware that is installed onto a computer masquerading as a legitimate program or code. Trojans can be installed through social engineering attacks such as phishing and website spoofing. Threat actors can use attack vectors such as email to trick a user into clicking a link that contains malware, or as a pop-up on a fake website that downloads an executable file of a malicious script. Trojans fall under the category of an active attack because malware installed on a machine can make changes to system configurations or notify the victim that changes were made to their account, such as an email saying that their password was updated. A backdoor is a pathway to access a computer or mobile device created by a developer for troubleshooting purposes or a threat actor by installing a rootkit or other form of malware. Backdoors are used in cyber attacks by threat actors to obtain remote access and control of another system's resources. This includes monitoring network traffic and installing different types of malware. There are two types of backdoors, active and passive. Active backdoors send a message to a command and control system that it is active and ready for instruction. Passive backdoors will set up a network listener on a pre-configured port after it's executed. Backdoors can fall into the category of passive and active depending on the type of backdoor used in an attack. A virus is malicious code that replicates by copying itself to another program, computer boot sector, and changes how a computer works. Viruses require users to interact with them to infect and spread within a system. They can take the form of an email attachment, a file that contains a malicious script once downloaded, or clicking a link on an infected website. Viruses fall under the category of an active attack, as viruses can modify system and application configurations, as well as copy, delete, or encrypt data. Return-oriented programming is a code reuse attack that is triggered using a memory corruption attack vulnerability. ROP attacks occur when a threat actor identifies ROP gadgets in the binary code of a system and exploits the return instructions by overriding the return address with the address of the first ROP gadget. As a result, the processor will jump to execute that gadget. Once the processor reaches the end of the first gadget, it will encounter another return instruction, which the threat actor can set to jump to the third gadget, where each gadget is followed in a consecutive manner under the control of the threat actor. Return-oriented programming falls under the category of an active attack because the threat actor is modifying existing code on another machine to overwhelm its processor. Social engineering is a form of manipulation that involves a threat actor interacting with another human to obtain sensitive information and access to systems, networks, or physical locations. The most common social engineering attacks include phishing, spear phishing, tailgating, whaling, baiting, watering hole, and scareware. The purpose of a threat actor performing social engineering on its target is to obtain access to resources and sensitive information for financial gain or other nefarious reasons. Social engineering falls under the category of passive attack since a threat actor is gathering intel and has to perform reconnaissance before carrying out an active attack. We've now reached the end of this presentation. Listed here are the sources that I used in completing this assignment.